Let's now discuss the state pattern. The state pattern, unlike many of its peers, is not really a widely used pattern. There don't exist a whole host of cases where the state pattern is applicable. In fact, the state design pattern is used in a very specific use case and it handles that one situation extremely well. And that is when you have a context with internal state and that state can transition based on external events, that's when you use the state pattern. Now, simple transition between states for any object is pretty straightforward. You don't really need a design pattern to solve that problem for you. But what if you had a whole host of states that could be present or that could apply to an object, and a whole bunch of transitions between these states? Each time you add a state, you just increase the number of transitions possible. That's where a state pattern will help you. Let's first imagine how a state pattern is laid out using this example. There is a diagram that you see on the right side of the screen. We'll be talking through that and figuring out what exactly the state pattern looks like. This diagram on the very right has a context. The context is any external object or any object which can be in a particular state. The context holds within it a variable called state. This state variable can be an interface or an abstract base class. And there are various concrete states that this context can be in. So if you look at the state hierarchy on the left, you see that we have a state as an interface at the top, and start state and stop state are the two concrete states that this context can be in. Now, moving back to the context for a little bit, note that it has methods which allow you to set a state on it and get a state on it. What the state pattern offers us is that the context does not know of transitions between a state. Any transition from start to stop or vice versa is known by the states themselves. That's how we manage the complexity of a whole variety of transitions to a whole bunch of states. If the states know, based on external events, what is the next state that has to be reached, the context can be abstracted from this and the information is only stored within the state. Basically, setting up the state pattern like this is much cleaner than resorting to large monolithic conditional statements to determine what the next state will be. Here, each state can treat itself as a logical unit and know where to go based on the external event that has occurred. Let's move on to understanding the state pattern using an example. We'll look at Java's media classes provided using the JavaFX framework. The three logical units that this setup is broken into is the media player, and the media view. The media is the actual audio or video file which you want played. This has duration, tracks, and other metadata that is associated typically with a media file. Note that the media can be both audio and video. In Java's support for media, a variety of file formats are supported in this media object, MP3 and MP4 being amongst the notable ones. So that is the media. The media player is what allows the user to all of the things that we want to do with media. We want to play it, pause it, stop it, seek to a different position to view a different portion of the clip, change its volume, add subtitles, equalize tracks. These are examples of all the actions that you can perform on media player, and these kind of translate to the events that are sent within the media player. The media view finally is what is displayed. Audio media doesn't really need a view, but video media does. The media view is where the video actually appears on screen. Now, in all of this, the media player has an important property that we're interested in right now. Given that we are studying the state pattern, it's obvious that the property that is important to us at this point is the status. The status of the media player specifies what state it is in at any point in time. Whether it's playing media, whether it has stopped, whether it has paused, so on and so forth. The status is set by using methods like play, pause, stop on the media player. And you can read the status by using the getStatus method. The states we've spoken about that the media player can be in are some of these. So there are 3 possible states that we know of at this point in time. Let's see what those are, and let's see what the transitions between them can be. So we have the playing state, the paused state, and the stopped state. So you can move from paused to playing and back, from playing to stop and back, and then you can move from paused to stopped and back. So these are the states that the media player can be in this at any point in time, and these are the transitions. Now here with 3 states, it's very easy to imagine the transitions. Let's say we needed to add new states such as ready, stalled, and unknown. So how do we do it? So we have the unknown state that can move to ready, and ready can move to playing. And then let's say we have this new stalled state, and from stalled, basically you can get to any of the other states. So you can move to paused and back, playing and back, stopped and back. Does this look manageable to you at this point in time? Not really. The sheer number of transitions makes maintaining code which handles these unmanageable. What we have is state explosion. Handling all of these new states and the transitions between them can become a real nightmare. The design pattern that's the hero of this class and which will help us out here is the state pattern. So what is typically the state pattern? What solution does it provide us for this problem? The state pattern basically says that the state itself should handle the transition outside it. So the state knows based on what external events what the end state is. Not some external class which will have a whole bunch of if statements. It's the state itself. The state only needs to worry about itself, an external event which acts on it, and what state it needs to move to based on this external event.